Hello everyone. In this video, we are talking about homework 5's problem 1. So now we have two different random variables, x and y, and defined as the union step function of x minus 1 minus u x minus 2 is x, and y is equal to uy minus uy minus y minus 1. And now we have a z which is equals to x plus y. And now we need to find the probability density function of z. So as we see the function, we know that x is changed on different positions, which is 1 and 2, and fy is changed on the position of y equals 0 to and y equals to 1. And the things they changed are in the really similar are in the same way. So if we can find the random function, we can also first move one unit step of x to the left as fx equals to ux minus 1, and then find the convolution find the probability density function of fz, and then move the function to run one unit to the right. So now first we can do in convolutional way, which is if we know that z equals to x plus y, it also equals to the convolution of the density function of x but to the z, and with the convolution of the density function of y on z. And now we can integral. We can find this the convolutional by integral with imply another variable. We call it alpha. So this will become from negative infinity to infinity fx to the alpha. And now which implies on the x, and we know that y equals to z minus alpha, and then the other part is fy z minus alpha, which is substitute the fx and fy here as first is u alpha and u minus u z minus alpha. No, it's alpha minus 1 and times u z minus alpha minus z minus alpha minus 1. And we can find the production of here and then take the integral out as first part is u alpha times u z minus alpha on delta alpha minus these two times same and alpha minus 1 times u z minus alpha minus u alpha times u z minus alpha minus 1 plus u alpha minus 1 times u z minus alpha minus 1. And for this fourth part, we can also change the integrals range and on certain I change the range and for shift left and right, I change it to be combine some similar parts together. So take for this one, we can define as 0 to x z, which with the variable of z, and as u alpha minus u z minus alpha. But now we times the unity of z, that will cause we can have the reasonable value on the reasonable value on the certain range. And also the next one, similarly, we can define as u alpha minus 1 and u z minus alpha, then times also the unit of z. Oh, 0 to z minus 1, which is because this one has been moved to the right with one value. That will be the same. Also for the next part, since this part we have moved to the right, so now is 1 to z, which become u alpha minus 1, and move this one to the left, and then is z minus alpha times z minus alpha, and also plus from this one. Alpha had to be moved to the right, so it's z minus 1. And also this part had to be moved to the right, so here the left boundary is become y, and then is u alpha minus 1 and u z minus alpha minus 1 delta alpha times u. They had to be moved to 2 units, so it's z minus 2. And then calculate together as all the unit function become 1. So here in the middle are 1, and here is times u z minus 1, and also plus 1 to 1 minus 1 alpha u z minus 2, and then result is z times here we have the integral now is z times u z minus z minus 1, and then u to the z. Here is also plus z minus 2, which is z minus 1 z minus 1, and then times u the unit z minus 2, And now we can give a plot here. If we see this part, we can see on the reasonable boundary, we have as this way. And now, well, these two are same. So first from 0 to 1 it grows, but if we take these two together, after this one is grows, but when we arrive to 1, the plot from this value will be go let down and then go this way. So it's the first two part. And then if we have this part, z minus 1 times u z minus 1, and it will go there and to one unit download, which will go like this way. So here is the third part. And for the first part, it will give us the value back. So from 1 and to 2, it will change back as it will change value. So for this one is z minus 2 times u z minus 2, because it is held value on 2, and now is finally the part only the value is on 1 to 2. And we know that we have moved one unit left to for fx, then we have to move it back. So move 1 unit right back. So the fz z will become from 1 to 3, and in this value. So and here is suppose z minus 1 this way. So the final answer will become z minus 1 u z minus 1 minus 2 times z minus 2 unit cell of z minus 2 and plus u z minus 3 times u z minus 3. And for the second part, still we have these two, the fx equals to ux minus ux minus 1 and fy, which this one has been moved to the left 1 unit, and fy equals to uy minus uy minus 1. And by geometric way, we can discuss on what will happen on 0 to 1 and 1 to 2 and 2 to infinite. If we have found, now we can find the continuous density function of big fz of z, which is equals to the probability of z less than equals to little z, and this one, and find the integral, find the the derivative of it will become the density function of fz. So let's replace the fx equals to x plus y is less than z. So now we can check what the value we can take for little z is. So if little z is in 0 to 1, which basically is what we can take the value from x, y, since the value change is only on 1, 0 for the new fx and the original fy. So now we have the plot for 1 and 1, which is what fxy is. If z is in 0 to 1, so we can take some value here and bound a triangle inside the square, bounded by x and y. So this part will have the z, which is less than x plus 1. And in this part, we can take the probability by the area, so which is the fz square. And for the second one, when z is in 1 and 2, so it's a bit larger, but not that larger to the boundaries as z is outside. So the intersection between z at x plus 1 is here, which is the probability for x plus y less than the little z. So, which is the area of the big triangle, which is 2 minus z square, z square over 2, and minus these 2 little square as z minus 1 square, or 2, which is the 1 over 2 z square plus 2z minus 1, and take the integral of this part. Fz is here, and so the small fz of fz is equals to z, and this and for the second range is 1, 2, and if we take the integral, and it is as negative z plus 2. And for second part, since second part, when z is larger than 2, since we know that x and y are won't be larger than 1, so the summation won't be larger than 2. And when z is larger than 2, it means we cannot take find any x and y that can larger than it. So the probability of x plus y less than z will be obsolete, be 1, since it definitely happens. And now if we take the derivative of it, we will have the fz equals to 0. So after we plot the square, give a plot of it, we will have from 0 to 1, it will have the z here. And for the next part, from 1 to 2, it will be fz of z, which is equals to minus z plus 2. And after that will be 0. So the final answer of it is z when z minus z plus 2 in z in 1, 2, and 0 in otherwise.